Okay, oscilloscope tutorial, take one. Off you go, Mike.
Okay, we have the oscilloscope, which obviously looks at voltage over time. Now, the first thing I want to mention is we've got probes. I'll show them on the camera. So we have two types of probe leads that we can connect to the oscilloscope. One is an oscilloscope probe, and the other one is a crocodile clip to BNC connector. Now, when we're going to take oscilloscope measurements on the oscilloscope side, we're going to use the probes. So, we can plug the probe into a channel 1 and 2. These are our two channels to the oscilloscope. One will be yellow, one will be green. We plug that in, and what's important to know, that we are going to take voltage measurements through one of these probes. Now, on the actual probe itself, you have what's called a probe multiplier, times 1 and times 10. And what that's going to do is that's going to affect the reading that you get on the signal as it's taken a measurement. So typically, they'll be set, because they're probes, they need to be set on times 10, which means that there will be 10 times attenuation going on the probe. So we can see at the moment on the oscilloscope, if we start the oscilloscope from the factory default, we can press this reset button here. And that will return everything on the oscilloscope back to a default setting. So it's a great place to start because you don't know what the previous person has done with the scope. So what that does is that turns on channel 1 for us. So we can check channel 1. If we click down here, and we can say probe, we can see that the probe is set to 10 to 1. What that means is my probe tip is now matched to the input of the oscilloscope. So if I measure 5 volts on the tip of this probe, it's going to be showing me the correct 5 volts there. If I didn't have that, then my reading is going to be off by a factor of 10. Okay, so that's just the initial setup stage. Now, with an oscilloscope, we have a vertical resolution, which is how many volts are shown in one of these divisions. So at the moment, as you can see down here, it shows that I'm at 500 millivolt a division. What that means is between this line and this line is 500 millivolts. So if I was to put my finger on the end of this probe, you can see how it changes. What it's doing is fluctuating between plus 500 millivolts and minus 500 millivolts. If I change that, I can change that with this scale option here. If I turn that, now you can see it's changed to 1 millivolt, 1 volt a division, which means that between this line and this line now, this one division is going to measure 1 volt. And I can keep going up, 2 volts, 10 volts, to whatever I need. So I'm going to leave that at 500 millivolts. Now the horizontal scale is how much time is represented between each division. So at the moment, if I look at my horizontal scale here, we can see that when I change it, these little values down here all change representing the time point. And up here it will tell you that I'm now at 50 microseconds a division. If I change it 100 microseconds a division, which means that from this point here to this point here is negative 100 microseconds. This point here to this point here is plus 100 microseconds. This point in the middle is what's called my trigger point, which is this T. That is where the oscilloscope starts to take its acquisition, starts the measurement. So, for my purposes here, I'm just going to turn this down until we have something reasonable like, let's say 100 millivolts a second. Okay. Now, interestingly, I've chosen a probe without the rounding bit. You can grab me another probe over there. Okay, so this oscilloscope also includes a signal generator. So to operate the signal generator, I come down here to this gen button found here. If I press the gen button, it loads up the signal generator options. And you can see I've got a sine function, a frequency, and an amplitude. So we can set the scope. We can set the probe up so it's exactly like that simulation. So to do that, what I'm going to do, we're currently using 1 kilohertz at 500 millivolts peak to peak. So I'm going to change my frequency. I'll just tap this frequency here, and I'm going to put 1 kilohertz in there, 1K. Now you can see it's changed to 1 kilohertz, and my amplitude is going to set so that it is 0.5, enter. Now I've got 500 millivolts peak to peak. Now I need to turn it on. To turn it on, I press the button here. My light's gone on here. I now have a signal being generated by the oscilloscope, and that signal is coming out of this port here. So to access that signal, I use the crocodile lever bit. What I can do is I can plug this BNC socket into here. Now, if I connect now my oscilloscope probe, here's the output of my signal generator, here's my oscilloscope probe. If I connect the negatives together and I put the tip of this probe onto this here, I'm going to see a signal. So, let's have a look at this signal. First of all, can't really see what's going on. It's very slow. So what I do is I'll change my horizontal scale to change the time acquisition scale. And now if I start reducing it, now we're at 1 second. It's going the wrong way. So I need to go the other way. Because that's going to take 1 second. You can see there it's gone even slower. So we turn it up, turn it up, turn it up. Now I start seeing my sine wave. 1 kilohertz sine wave. I'm looking at 1 millisecond of division. So this division shows 1 millisecond. Now let's look at the voltage level. Remember, I set 500 millivolts peak to peak. So that's going to be 5. I can see a 500 millivolt here and a minus 500 millivolt here, so it's about half of that, which is correct, 500 millivolts peak to peak. But I can see it better if I change the vertical scale, which is changing the voltage. You see? Okay, so now we've got a signal that looks a bit like two sine waves together. The reason why that's happening is our trigger point. Our trigger point is here, and we have a trigger level. The trigger level can be controlled here. If I start changing that trigger level, moving it up as possible, you can see how that is affecting where exactly my scope is moving. Now, this scope is overlaying two triggers in one hit. To turn that off, what I can do is I can look at my menu. Yeah, it's brought this menu up here, and I can put a bandwidth on there, 20 megahertz, so that I reduce the amount of acquisition frequency that's being used by the oscilloscope. I've told the oscilloscope that I don't want to be looking at, because this oscilloscope is, it doesn't actually tell me on here, but it's probably 300 megahertz. 300 megahertz bandwidth. So there's a lot of noise, a lot of high frequency noise that's picking up. When I put this bandwidth limiter on to 20 megahertz, it's rejecting that noise. And I don't need anything more than 20 megahertz because I'm looking at a 1 kilohertz signal. So I don't need 100 megahertz or so. So you see that when I turn the bandwidth filter on, now I've got this lovely clean sine wave. And when I move the trigger down, you can see that this point here is where it's triggering. Yeah? So what I'm doing now is I'm generating a 1 kilohertz sine wave coming out, and I'm sampling that same signal going back into the scope, and I can see here that I have minus 250 millivolts here, positive 250 millivolts there, which makes 500 millivolts peak to peak. And along the side here, I add a measurement if I want to make sure I understand what's happening with this signal. I can press the measure button here. Okay, they say that I want to put the measurement in place 1. My measurement is a peak-to-peak measurement, and my source is channel 1. So if I turn that on, we can now see down here that voltage peak-to-peak is about 521.46 millivolts. There's a little bit of loss in the leads going on there. And if I turn on another measurement, and I change this measurement to place channel 2, and then I can tell it that I want to measure the frequency of this signal. Now down here now it's telling me that I have a frequency of 1 kilohertz, which is exactly what I'm putting out of the signal generator. Okay, anybody any questions? No? Excellent. Now, have a quick look at the power supply while we're here. Turn this power supply on. problem with the power supply. Right, this is a 3-channel power supply. Now we're going to use this to represent the battery in our circuit. Okay. So to set this up correctly, I want to use channel 1. So I press channel 1. I want to set this to be 12 volts. So I'll press the voltage button, and you can see the cursor now is over here on this here. I can use these arrows here to move the cursor. So I'll move it. I'll move it left 1, and it goes there. I turn the knob. I put that up to 12 volts. So, now it's giving me 2.8 amps output. Now with 2.8 amps, it's way more than my circuit needs. And if there's a fault in my circuit at 2.8 amps, a component is going to blow up, burn, explode, whatever. So what I can do is I can set this power supply to current limit the amount of current going to my circuit. So if there's a fault in my circuit or a short, the power supply will stop giving current at the set limit as opposed to a component blowing up. Yeah? So to change that, I press the current button. Again, the cursor comes on. I'll move the cursor over and I'll put it right down. For our needs, we don't even need any more than 400 milliamps. Yeah? So now I've got 12 volts, 400 milliamps. To actually turn that on, and it will be coming from channel 1 here. To turn that power on, I need to press the output button. When I press the output button, it turns green, and it shows that I'm delivering 12 volts, and this is the current that's currently being consumed. Nothing is connected, so there's no current. If there was a fault in my circuit, this would be at 400, and this voltage will drop, because this is current limited to stop an explosion or something nasty happens. If I want to turn the power off, I press this output button. Okay?
What is the reason for this channels? Where there are 3 channels?